Hi, I'm Kayla, and in this video I'll be going over how to solve a linear equation using elimination. So in a previous video I used substitution. If you're completely new to solving a linear equation, you should look at the substitution one first because it makes more sense conceptually. So elimination and substitution can be used in either system. Some people have a preference for which one. I prefer substitution, but it can be up to you. So let's look at two lines here, and this will be different than the last one I did. Okay, so now you're seeing this on a test, and they've said to use elimination. So what you first want to do is make sure that they're both in the same form. So this one, it's not really in any form, but it could be in standard form or it could be in mx plus b form. In this case, it'll just be easier to put this into standard form. So let me rewrite both of these. And then you want to have the x's and y's line up. That's the first thing. Okay, now this was my first equation, and this was my second. So hopefully everyone can see how I went from here to there. I simply moved the 1 over, and I switched the x and y. Now when I look at this, I have two options. What I'm trying to do is that these are two lines. I want to know when they intersect. Now, as we've already talked in substitution, what intersection is, it's the solution, it's where the x and the y's are equal. So if the x's and y's are equal, then they can be eliminated. Now we look at this, and what we're saying is basically a subtraction. So if you remember from like grade school, you had 4 minus 4 is equal to 0. That's what you want to do. There's no difference between saying 4 minus 4 equals 0 than there is to say 4x minus 4x is 0. Now I could also add these. If this was negative 4x, I could say a plus. So negative 4x plus 4x is 0. So even though elimination means subtraction, you don't have to do that. You can also do addition. What we want to say is we want to look here and say what operation is going to eliminate my x's or what operation is going to eliminate my y's. In this case, I say, does 2x minus x give me 0x? No, it doesn't. It gives me 1x. Same thing. There's no way to easily subtract any of these to get rid of them. And we're looking to get rid of an x or a y. We don't want to get rid of like 3 minus 1. We're not trying to get the constant to be 0. That doesn't make any sense. What we want to do is eliminate one variable. Eliminate x or eliminate y. Because 1, they're the same because they're intercepting. And 2, because we can't solve this equation with two variables. So in order to solve this type of equation, you need to have just one variable in it. So now I need to look here and I need to say, how can I make one of these equations, like what kind of multiple can I apply to them so that I could eliminate something? So for instance, if this was a 2x and I subtracted them, I could get rid of my x's. So then what I'm going to say is what can I multiply this by in order to make x equal to 2? And of course, if I took this whole equation and I multiplied everything by 2, I would have a 2x, and that would work. You may be looking at this and saying, oh, couldn't I do something to y's? So yes, you could. Now that would be an extra step. You could multiply this by 3, which would give you 6y, and this by 2, which would also give you 6y, add them together, and then you would also eliminate the y's. But we see that's going to be an extra 2 steps rather than just 1 step for the x's. And I'll show that at the end, how you could have done the y's instead. So what I'm going to say is equation 2 times it by 2. So 2 is now equal to 2x plus 4y, because that's 2 times 2y, minus 2 is equal to 0. Now here's a couple mistakes that everyone makes. First, you don't multiply the constant here. So negative 2 became negative 2 for negative 1 because I have to multiply that as well. And sometimes people will multiply the end, or they'll maybe add 2 to it. But 0 times 2 is of course 0, so don't accidentally change that to 2. Now I'm looking at this, I'm saying, okay, I like my second equation, this is great. If I do equation 1 minus equation 2, that's going to be 2x over 2x, and that's going to get rid of them. So let me write this both out again. So remember, 1 is 2x minus 3y plus 3 is equal to 0. I'm doing a lot of writing here, you don't have to do this much. This should all be, really, this should be one step. You would have just multiplied it and then subtracted it. And then my second equation, which is now changed, and notice I am lining up my variables. So what you want to do is draw a line under this. This says, hi, I'm using elimination. Then on the left here, you say what you're doing. Because remember, you could add them together. That's not what we're going to do. We're going to subtract. So make sure you put the subtraction there. And then we can see that 2x minus 2x is 0. Negative 3y minus 4y is negative 7y. And I've just made these equations up again, so it's probably going to be a fraction. And then I have 3 minus a negative 2. So make sure you take into that account the negative. That's obviously 3 plus 2. That's going to be 5 is equal to 0. So then I have negative 7y is equal to negative 5. Y is equal to 5 over 7. And don't put a decimal, leave that as a fraction. That's great. Okay, so now I have two lines, and I don't know what they look like yet because these are standard form, so for all I know they look something like this. I usually like using substitution because you put it into, or you can, to nice y equals mx plus b first, and you can see how they graph. Elimination, you don't do that step. So you could, but we didn't do it here. So we have two lines, they intercept somewhere. And remember, this is what we're solving for. Again, watch the substitution first because I go over what this means. We're looking for the x and y coordinate of where the two lines intercept. So right now, I just solved y equals 5 over 7. What I've solved for is the y value of this intersection point. A lot of people will stop here. Don't stop at this point. If you're looking for a solution, you're looking for a point, which means an x and a y. So you have to solve for the x as well. Now, at this point on, it's the exact same as the substitution. What we did was we went back and we substituted this value, y, which we solved for, into one of the original equations. It doesn't matter which one, because they're both intercepting at the same point, which is that the y equals 5 over 7 point. So 2y plus x equal to 1. This is my second equation, so I'm going to substitute my y into this one. So now I have 2 times 5 over 7 minus 1 is equal to negative x. And then I can multiply this in and subtract the 1, so I get 10 over 7. It would have been easier if I moved the 2y over, but that's okay. Minus, and then this needs to be a common denominator. And I chose that because that's 1 over 1, so 7, and then 7, and then I would get 3 over 7 is equal to negative x. Of course, move the negative over, and you get negative 3 over 7. Okay, so now my final point of intersection, sorry, is negative 3 over 7 and 5 over 7. Okay, so I have that there, and now I've solved my solution. I have my solution, which is that point, and we're done. So thanks for watching.